options, boot menu. So we press escape. So now we want to map the virtual CD-ROM to the ISO image that we downloaded. So the ISO image is just on my C drive, but you could have it on a host data store or whatever you want. So we're going to connect that to a ISO image on local disk. And we're going to go to the desktop and select the ISO. Now the VM's virtual CD-ROM drive is mapped to that, so when it tries to boot from the CD-ROM, it's going to boot from that live CD and not from the operating system that's on the virtual disk. So now we're ready to select CD-ROM drive. And here you can see GNOME partition editor. You can just go with the defaults. And this may look scary, but it's basically just Linux booting. At all the prompts here, you can pretty much go with all the defaults in most cases. So the language, choose a language, the default is English, and then choose 0 to continue to start to the GParted automatically. Optionally, you can change the video mode with 1. And here we go, it's loaded. It's showing our existing 8 gig disk partition, and it's also showing the 4 gigabytes of unallocated space. So to resize this, we just click on the resize button here, and it prompts up this, brings up the screen here. And the easiest way, you can just drag this over to use the remaining space, or you can just type it in here. Be careful here, if you get the 4-way arrows, it's going to try to move a partition. You don't want to do that. You want to grab the very end and extend it all the way over. So it's using all the free space. And then you click resize. And then you got to click apply or it's not going to take effect. And just say apply. And you can look at the details here. And it says here it's successfully completed. So we can close this. And we can close this, and we can now exit. And go to reboot. So this is going to shut down the GNOME partition editor and just going to reboot normally from the operating system from this point. And since we had that long delay in there, it's going to take a bit longer. Here it goes. Don't forget to remove that delay that we put in there. And usually it's going to run check disk here because Windows has seen that something has happened to the disk. So it's just going to do a quick check disk on the disk just to make sure everything is intact and everything's okay with the disk. This will just take a minute to run, and then once it completes, it'll boot normally from that point. I did the check disk, and now it's going to reboot. Okay, it started up. If we log in, and go to Computer Management, select Disk Management. And while that's starting, we can go here to Windows Explorer. And if we go to the C drive, you can see the C drive is now 12 gigabytes. So the operation was successful, and we successfully expanded the C drive from 8 gigs to 12 gigs to take advantage of that extra room that we did by expanding the virtual disk. And here you can see is the partition. There's a CD-ROM drive here, but here's a partition It's now 12 gig, and we've successfully increased the size of the operating system partition to match the increased size of the virtual disk. So that's all there is to it. In another video, we'll show you how to do this in Windows Server 2008. The gpart-ed method is only typically needed for boot partitions in Windows Server 2003, and there's some other operating systems that don't let you expand partitions. You can also use it for that. If you have any problems with gpart-ed, be sure and check out their website and their FAQ here. It gives you some answers to some problems. Sometimes you may have problems with Windows not booting. There's a couple extra steps that you need to do in that case to make sure to change the drive letters around so Windows can boot successfully. And that's it. That's all there is to expanding a operating system partition. Okay, we're also going to show you how to extend a disk into Windows Server 2008. It's a lot easier there that you don't actually have to use a third-party utility to expand a boot partition. So to do that, it's native to Windows Server 2008. You just launch the Computer Management and go to Disk Management. It's going to display the disk information. You see here that we have a C drive that is 15 gigabytes in size, and we extended the virtual disk on this server to 24 gig. So there is 9 gig of unallocated space. So now if we want to make the C drive use that space, so we're essentially extending the C drive to 24 gig, we simply select the drive, right click on it, and select Extend Volume. And the wizard will launch. And we're just basically, it's selected here, it sees that disk 0, and it's going to allow us to extend it by that amount of disk space to be a total size of 24 gig. So we just leave it as is. You can make that smaller if you want, or just use the whole amount of disk that you extended the virtual disk by. So we're going to leave it at 9 gig. Click Finish, and it's as simple as that. You now have a C drive that is 24 gig, so it grew from 15 gig to 24 gig after we extended the virtual disk from 15 gig to 24 gigabytes. So that's all there is to it with Windows Server 2008. It's definitely a lot easier. You can use the built-in computer management to extend your OS partitions. You don't have to use a third-party utility. So that's it. Some operating systems will only let you increase the size of non-boot disk partitions. If this is the case, an alternate method to extend boot partitions is to use a live CD with a disk partition editor like gpart-ed. You can also use the VMK FS Tools command line utility to increase virtual disk sizes, but this requires that the VM be powered off. Here are some tips and best practices for VMFS volumes. By default, VMFS volumes are created with a 1 megabyte block size, which allows for a single virtual machine disk file to be created up to 256 gigabytes in size. If you try and create a virtual disk larger than 256 gigabytes when using a 1 meg block size, you will not be allowed to. Once you set a block size on a VMFS volume, you cannot change it later. Instead, you need to move all the VMs from the volume, delete the volume, and then recreate it with a new block size. Therefore, you should make sure you choose a block size that works for you based on your current and future needs. The block size choices and related maximum virtual disk sizes are listed below. 1 megabyte block sizes allow for a maximum disk of 256 gigabytes, which is a default. 2 megabyte block sizes allow for a maximum virtual disk size of 512 gig. 4 megabyte block sizes allow for a 1 terabyte maximum virtual disk file size. And 8 megabyte block sizes allows for a 2 terabyte maximum virtual disk file size. Choosing a larger block size will not impact disk performance and will only affect the minimum amount of disk space that files will take up on your VMFS volumes. Block size is the amount of space that a single block of data takes up on the disk, and subsequently the amount of disk space a file takes up will be based on a multiple of the block size. However, VMFS does employ sub-block allocation, so small files do not take up an entire block. Sub-blocks are always 64 KB in size regardless of the block size chosen. So there is some wasted disk space, but this is negligible as VMFS volumes do not have a large number of files on them, and most of the files are all very large and not affected that much by having a larger block size. Here are some more tips and best practices for VMFS volumes. In most cases, it's probably best to use an 8 MB block size when creating a VMFS volume, even if you're using smaller volume sizes under 300 GB, as you may decide to grow it later on. You should never grow a LUN for use with vSphere greater than 2 TB. The actual maximum size of a LUN in vSphere is 2 TB minus 512 bytes, or 1.9999 GB. If you try and create a volume that is exactly 2 TB, you will get an error message that says, "Failed to get disk partition information." The reason for this is that the extra 512 bytes are needed by ESX for the configuration overhead information that is written to the LUN. So if you want to create a 2 TB LUN, you should specify it as 1.99 TB instead. This behavior is new to vSphere. In VI3, you could create 2 TB LUNs, but the 512 bytes were still needed for configuration overhead. Because the LUN was provisioned as the full 2 TB, it could cause an out-of-space condition if the LUN was completely filled up, which could corrupt the LUN. As a result, the safeguards were put into vSphere to allow for that additional necessary 512 bytes to not get overwritten by data on the LUN. The 2 TB limit is not actually a VMFS limit, and is actually a limitation of the underlying SCSI-2 standard that vSphere uses, which can only address 2 TB of disk space. The logical volume manager that vSphere uses concatenates multiple LUNs as extents into a VMFS volume up to 64 TB in size when using the maximum 32 extents that are 2 TB in size. If you do present a LUN larger than 2 TB to vSphere, what happens is only the space above 2 TB is used for the VMFS data store. So if you presented a 2.5 TB LUN, the VMFS data store would only be 500 GB in size, and you would be wasting 2 TB of space. So make sure you keep your LUNs below 2 TB in size. Having too many VMs on a single LUN can cause problems with metadata locking issues, also known as SCSI reservations. However, this number can vary greatly depending on the I/O requirements of the applications running on the VMs. Here are some more tips and best practices for VMFS volumes. VMware's maximum configuration document states that 256 VMs per volume is the limit. But this is not a hard limit, and in reality can scale much higher. For VMs that have very light I/O workloads, such as application servers, you could easily fit 100 VMs per LUN. You should consider fewer VMs per LUN, maybe 8 to 10, if you will have very disk I/O intensive applications running on them, and you should consider more VMs per LUN, maybe 20 to 22, if you have low to medium disk I/O applications running on them. For very low disk I/O applications, you can scale much higher. You should also factor in I/O per second, which is known as IOPS, measurements, which play a key role in sizing your LUNs properly. To do this, you will first need to determine the number of IOPS required by your application workloads using a performance monitor. Once you know your IOPS requirements, you can then compare it to the number of IOPS provided by the storage subsystem backing the LUN. There are performance benchmarking tools available, like Iometer, that can measure the IOPS of your host storage when run inside of a VM with a virtual disk on that storage device. Once you figure out how many VMs you will have per LUN, you should then look at your disk storage requirements per VM and also allow for additional storage for things like vSwap files, log files, and snapshot files that will also be created in your VM's working directory. How much extra storage you will need for your VMs will be heavily influenced by how much you plan on using snapshots with your VMs. A general rule of thumb is to allow for about 20% additional disk space in addition to the size of the VM's virtual disks. Here are some tips and best practices for hot extending virtual disks. As I mentioned earlier, you can extend the virtual disk of unsupported operating systems, but they will not see the additional space until they are rebooted. You can also use VMware's free vCenter Converter application to resize virtual machine disks. Converter will allow you to either increase or decrease the size of VM's virtual disk as it clones an existing disk and just creates a new VM with the new virtual disk and then copies all the data from the old disk to the new disk. VMware Converter is a must-have application that can perform physical to virtual and virtual to virtual conversions. Instead of increasing the size of existing disks, you can also hot add new virtual disks to a VM. If the operating supports it, you can then use those disks immediately without rebooting the VM. If you increase the size of thin disks, they will remain thin as only the provision size is increased and not the actual used size of the disk. Here are some links to some free utilities that can help you with virtual disks. GNOME Partition Editor is a live CD that you can boot a VM from and resize the disk partitions on it. VMware Converter can perform P2V and V2V operations, and Iometer can help you benchmark the performance of your virtual disks. Being able to grow VMFS volumes and resize virtual disks is a great feature as it allows you to easily correct sizing decisions that you may have originally made that did not work out later on. In addition, it helps prevent over-allocating storage, as you know you can easily change it later on. In this lesson, we have learned how to grow VMFS volumes and how to extend virtual disks, and also learned some tips for sizing your storage LUNs properly. That concludes this lesson on VMFS volume grow and virtual disk hot extend. Thanks for watching, and I'll see you in the next one.